Theorem of Parallel Axes. Theorem of Parallel Axes. Theorem of Parallel Axes for moment of inertia. For moment of inertia. For moment of inertia. In diagram, we have a rigid body, and this is an axis AB which is passing through the center of mass of the rigid body. C is the center of mass of the rigid body, and we can consider an axis. We can consider an axis AB which is passing through the rigid body, and this rigid body rotates about the axis AB, and moment of inertia of the rigid body will be IAB about the axis AB. Similarly, we can consider another axis PQ which is parallel to the axis AB. If the rigid body rotates about the axis PQ, if the rigid body, the axis PQ is passing through the point D, and if the rigid body rotates about the axis PQ, then moment of inertia of the rigid body will be IAB, IPQ. And this is a perpendicular distance. Here R is the perpendicular distance between the two parallel axes. Capital M is the mass of the rigid body, and this rigid body may be three-dimensional or two-dimensional body. It states that, this theorem states that the moment of inertia of a rigid body under bracket three-dimensional or two-dimensional body, three-dimensional or two-dimensional body, three-dimensional or two-dimensional rigid body. That means it states that the moment of inertia of a rigid body about an axis PQ is equal to the moment of inertia, is equal to its moment of inertia, equal to its moment of inertia about an axis AB, which is passing through the center of mass C of the body, passing through its center of mass, C of the body, of the rigid body, is equal to its moment of inertia about an axis AB passing through its center of mass C plus the product of mass of the rigid body, product of the mass of the rigid body, and the square of the perpendicular distance between the two parallel axes. Product of the mass of the rigid body capital M and the square of the perpendicular distance, between perpendicular distance R, the square of the perpendicular distance R between the two axes AB and PQ. So if we consider the rigid body, if the rigid body rotates about the axis AB, the body will have the moment of inertia IAB, and if the rigid body rotates about the axis PQ, the body will have the moment of inertia IPQ. R is the distance between the two parallel axes, So according to the theorem of parallel axes, according to the theorem of parallel axes, not axis, it should be axis. IPQ equal IAB plus MR square. IPQ equal IAB plus MR square. IPQ is the moment of inertia of the rigid body about the axis of rotation PQ, which is the parallel to another axis AB passing through center of mass of the body. IPQ equal IAB plus MR square, which is the moment of inertia of the rigid body about the axis PQ, about the axis of rotation PQ. Also, IAB is the moment of inertia. IAB is the moment of inertia of the rigid body or the body about the axis AB, passing through its center of mass C, and perpendicular to the body, passing through the center of mass, under bracket C of the body, center of mass C of the body. C is the AB is the axis which passes through the center of mass of the rigid body, and R is the perpendicular distance. Between the two parallel axes PQ and AB. Theorem of parallel axes for moment of inertia. Theorem of parallel axes for moment of inertia. Theorem of parallel axes is applicable for three-dimensional or two-dimensional body, for a rod, a ring, a disc, and a solid sphere or hollow sphere, etc.